Okay, friends. Now we'll see now you know the problems what we are faced in TRF receiver. Now that we can overcome by using super heterodyne receiver. Okay, and this is the only one receiver which is a very important receiver. Okay, now before we designing the process of this particular receiver, what is the principle of that particular receiver? Okay, then what is the principle of TRF receiver? The incoming signal is passed through several amplifier stages, then go for demodulation. Now similarly here, the super heterodyne receiver principle is the incoming signal, see here, incoming signal means high frequency signal, is down converted to a fixed frequency called as intermediate frequency. High frequency RF signal is down converted to a fixed frequency called as intermediate frequency, then go for demodulation. Then means what is the job of this? Now see here, RF amplifier is down converted to IF. RF amplifier is down converted to IF. RF amplifier is down converted to IF, which means that now this is the RF amplifier which is down converted to IF. Now see here, this RF amplifier is down converted to IF, intermediate frequency. Then whose job is the down conversion? RF high frequency signal is down converted to IF means now this down conversion job is because of mixer. Now this IF, now that IF intermediate frequency is go to the AF stage. Now this is nothing but demodulator. Okay, this is the principle of super heterodyne receiver. The incoming signal is down converted to a fixed frequency called as intermediate frequency, and then go for demodulation with the help of demodulator, and this is so RF stage to IF stage to AF stage. Okay. Now with the diagram also I can easily explain such that you can easily understand. Clear or not? Incoming signal is down converted to a fixed frequency called as intermediate frequency, then go for demodulation with the help of a demodulator. Okay. Now see here, for example, now this is a low frequency range. This is the high frequency signal, right? Fs, right? Now this is a high frequency. Let us assume, for example, 1000 kHz signal, and that is down converted to what is that? That is down converted to IF stage. That is down converted to IF. IF means intermediate stage. Now this is the intermediate frequency. Intermediate frequency is fixed for a particular receiver. Now this is the intermediate frequency. Okay. Now the intermediate frequency is 455 kHz per AM. This is 455 kHz per AM. Now from here to here the job is mixer. Mixer is used to down convert the signal. From down converted IF stage to AF stage is a demodulator. Therefore now after demodulator, then you can get back the low frequency information signal, which is nothing but AF signal. Clear? Now this is AF signal. Now this is IF signal, intermediate frequency signal, IF signal. And this is RF signal. Now this RF to IF, with the help of mixer. Now this IF to AF with the help of demodulator. So if you understand these things, then the super radio and receiver is very, very easy. Okay, note down. So this is the principle of super radio and receiver. Now according to this particular principle, then you construct the receiving section. And in the same way, what are the problem we are faced in the super radio receiver, TRF receiver should be overcome here. Okay. Now this is a RF amplifier. Before that we will see some characteristics of the AM and FM, which is very important. Now this is AM receiver. And this is FM receivers. Now technical specifications. Now the carrier frequency, and the previous sessions also I am explaining. Now this is the carrier frequency 550 kHz to 1650 kHz. And the carrier frequency here is 88 MHz to 108 MHz is the carrier frequency. Okay, carrier frequency of a modulated signal. Now intermediate frequency is fixed for a particular receiver, then the intermediate frequency is fixed as 455 kHz here, and the intermediate frequency for FM is 10.7 MHz. And you know that the highest frequency here is band limited to 5 kHz of a audio signal. Therefore bandwidth of each AM station, which is nothing but 10 kHz, you know that. So almost all audio frequency is reproduced here. So highest frequency is 20 kilohertz. So the bandwidth of each FM tune station is 2 into beta plus 1 into FM. You already know that FM requires more bandwidth compared with AM. Therefore, this is 200 kilohertz. Right? So now see here, this is the intermediate frequency, carrier frequency and bandwidth. Number of AM stations. How many number of AM stations accommodated over a bandwidth of 10 kilohertz with a bandwidth of 10 kilohertz between 550 to 1650. Now see here, the number of tuned stations, number of AM stations is nothing but 1650 kilo minus 550 kilo by each station bandwidth is 10 kilohertz. So 1600 minus 500, 1100. 50-50 cancel. 1100 minus by 10k is 1110 stations. The number of AM stations within this particular AM band is 110 stations are multiplex. 110 stations are multiplexed within this particular carrier frequency boundary. So the number of FM stations within this particular carrier frequency range is 108 megahertz minus 88 megahertz by each FM station bandwidth is 200 kilohertz. So the number of FM stations are clear or not? So this is the technical specifications of designing for AM, and this is the technical specifications for designing of FM. This is required, okay? And here the practical deviation is, the maximum practical deviation is, the maximum frequency deviation practically is 75 kilohertz, okay? You know that, okay? And FM requires more bandwidth, that's why this is high. Note on this. So the number of FM stations is around here 100, I think. Clear or not? Yes. Now see here. Now this technical specification is required, okay? For designing of AM and FM receivers. Now we'll see the super heterodyne receiver. Now this is the incoming signal, is a modulated signal. Now this is RF amplifier. Now this incoming signal is down converted to a fixed frequency. This incoming signal is down converted to a fixed frequency is called as intermediate frequency. That down conversion job is mixer, right? So this is the local oscillator. Now the local oscillator will generate FL and it should be greater than this. So this is multiplier and band pass filter. This is a part of the mixer, okay? This is a mixer section. This is RF amplifier. Okay, you know the job of the mixer, therefore directly I will write here. Okay, this is the mixer section. Multiplier, low class leader, band pass filter. This is the total mixer part. Now this mixer FL minus FS is down converted to IF. So this is the intermediate frequency. Now this is intermediate frequency is nothing but IF amplifier. IF amplifier. Now see here. Now what is this intermediate frequency? Intermediate frequency is 455 kilohertz actually. The intermediate frequency is 455 kilohertz. Now for easy operation, for easy explanation of this analysis, I just take this IF as 500 kilohertz. Okay. Now let us assume this IF, for example. Okay. Okay. Now for explanation, for operation of this example. Okay. So let us assume intermediate frequency is 500 kilohertz, and I want to tune the signal, the incoming signal or a tuned station frequency is 1000 kilohertz. Okay. Let us assume, for example, for better understanding, Fs or Fc. So this is 500 kilohertz. Now this is the intermediate frequency. Now this is IF amplifier. This is the IF amplifier. Now see here, this IF amplifier consisting of tuned circuit. This IF amplifier consisting of tuned circuit. Sir, what is the purpose of this tuned circuit? Now I will come to that particular point. Now you tell me the incoming signal is an amplitude modulated signal. Now the first it should be receiving and down converting. Now after down converting, before this carry frequency is 1000 kilohertz, when it is down converted, then the carry frequency will become 455 kilohertz or 500 kilohertz. Therefore it is also a modulated signal with a carry frequency of 500 kilohertz. Therefore we require a band pass filter here. Therefore this tuned circuit will act as a band pass filter. This tuned circuit will act as a band pass filter, but the gain versus frequency characteristics of this tuned circuit is fixed. Now how you can say that the gain versus frequency characteristics of this tuned circuit is fixed? Yes, because the center frequency is fixed here. Any signal is down converted to IF. IF which is equal to 455 kilohertz, but in example 500 kilohertz, and maintain a bandwidth of, and this is also fixed, and maintain a bandwidth of 10 kilohertz. This is fixed. So here this band pass filter, this tuned circuit, you always having a fixed characteristic. The fixed characteristics of this tuned circuit, the gain versus frequency characteristics of this tuned circuit is fixed with intermediate frequency, resonant frequency is 500 kHz or IF, and having a bandwidth of 10 kHz fixed one. So whatever the incoming signal, that incoming signal is down converted to IF, then that modulated signal with a carrier frequency IF is opened a gate, because this IF amplifier is having a band pass filter. This tuned circuit will act as a band pass filter. This is the tuned circuit characteristics at IF stage. Okay, this is at IF stage. Okay, now I am not interested in the IF stage. I want a starting stage. What happened here? Okay, now my question is, now the question here is, now clearly, okay, I just have a step by step. See here, now this is step 1. What is step 1? The receiver is to tune. First, our aim is, aim of this receiver is tuned to 1000 kilohertz signal. Okay, so what, for the purpose of designing of this receiver is to select the incoming signal with a incoming signal of carrier frequencies 1000 kilohertz. So aim of this receiver is tuned to 1000 kilohertz, which means Fs, which is equal to 1000 kilohertz. What happened now, you tell me? If this Fs is equal to 1000 kilohertz, now first of all, the low class oscillator, this low class oscillator frequency is adjusted, am I not? So in step 1, the low class oscillator frequency is adjusted. The low class oscillator frequency is adjusted to 1500 kilohertz, 1500 kilohertz, such that down converted to IF, such that it is down converted to IF, which is equal to 500 kilohertz. Is it right or not? Because FL minus Fs, which is equal to IF. What is FL? 1500 minus Fs is 1000. 1500 minus 1000, which is equal to 500 kilohertz. Okay. Now, whenever then this mixer is down converted to 500 kilohertz modulated signal. Now here, this is, what is the signal here? Now this is the signal which is down converted to, now this is down converted to IF, which is equal to 500 kilohertz. Okay, now the first step is completed, right? Now this is the first step. The incoming signal is down converted to IF by adjusting the low class oscillator frequency. Now the step 1 is totally, I just write with blue line such that you can easily understand. Okay, $500 kilohertz. Clear? Now what happened? Now step 2. Okay, now for example, assume that the receiving antenna, is receiving a 2000 kilohertz signal, means Fs is equal to 2000 kilohertz signal. Whatever the signal is coming, the mixer job is to adjust the low class oscillator and down convert it to IF, which means that then the low class oscillator frequency is adjusted to 2500 kilohertz such that down converted to IF, which is equal to 500 kilohertz, which is FL minus Fs, which is equal to IF. FL minus Fs, which is equal to IF. Now this is the low class frequency is adjusted to 2500 kilohertz such that a down converted to IF. Now see here what happened now. Now this is the 2000 kilohertz signal is coming here. Unfortunately, our receiver is receiving this 2000 kilohertz signal. Now this is 2000 kilohertz signal, Fs or Fc, which is equal to 2000 kilohertz, and it is also down converted to IF, which is 500 kilohertz. Now what happened? Now the IF amplifier is now in the confusion state, because IF amplifier is a fixed tune circuit, fixed band pass filter with IF is 500 kHz with a pass band of 10 kHz. Now here 500 kHz, 10 kHz, 500 kHz, 10 kHz. Now IF amplifier is confusing that. Now which signal I want to accept? Both are appears to be same. Now, but I am designing for this signal or I am designing for the second signal. Okay. Now therefore, now this is not the original signal. Our aim of the receiver is tuned to this one. But unfortunately, our receiving antenna is receiving 2000 kHz signal. Am I not? By creating, now the IF amplifier is in the confusion mode, because by seeing this image, okay. Now this is a image of this one or not? Both are appears to be same. But this image is coming because of which signal? This image is created by this 2000 kHz signal. Now this 2000 kHz tuned frequency signal is creating an image, and causes this 2000 kHz signal is creating an image and causes interfere to the required signal, interfere to the required signal. That frequency is called as image frequency. That frequency is called as image frequency because it is creating an image. The 2000 kHz signal is creating an image to the required signal. Therefore, this is called as image frequency. Now, this 2000 kHz signal is creating an image and causes interference to the required signal, and that frequency is called as image frequency. FSI, image frequency. Now you tell me, if you understand this example, what is image frequency? 2000 kHz or 1000 kHz or 500 kHz? Now this is 500 kHz is a mixer job, but whatever the signal is coming is down converted to IF. Is it right or not? Therefore, this 2000 kHz signal is causing interference to the required signal. Now that 2000 kHz signal is called as image frequency, represented by FSI, and this image frequency is calculated as FSI, which is equal to Fs plus 2 into IF. This FSI, which is equal to Fs plus 2 into IF. See here, this is FSI, which is equal to Fs is 1000 kilo plus 2 into IF is 500 kilo. So which is equal to 2000 kHz is the image frequency. Okay, note down this. Clear or not? But the students are raising one doubt. Sir, this 1000 is okay, but 2000 is not in AM range. Then how your receiving antenna will receive that, sir? So it won't come everywhere. It will never come. So how this we can say that causing an interference? This is very good question. Understand or not? So 1000 is okay, sir, but 2000 is not within the AM range. How your receiving antenna is receive this signal? So you are saying that this is coming and causing interference, image frequency, all these things. Is it right or not? So yes, that is also very good question. So for that I just give one small explanation. See here. Now let us see, for example, carrier frequencies. I am writing Fs. Okay. So here this is Fs. Fs is 600 kilohertz. Means like this. Here 1000, no? This is Fs 600. Then tell me what happened. Now this is 600 kilohertz is down converted to 500 kilohertz by adjusting the local oscillator frequency, by adjusting the local oscillator. So which means that FL is adjusted to 1100, sorry, 1100. FL is adjusted to 1100 such that FL minus Fs, which is equal to IF. 1100 minus Fs is 600, which is equal to IF, which is nothing but 500 kilohertz. Like this is process, the same process whatever I am explaining. Next, now next one is 800 kilohertz. Next one is like this, same, all are Fs. Okay, thousand kilohertz, and so on like this. Now you see here 1600 kilohertz. 1600 kilohertz. What happened? Now this is Fs. Now you tell me. Now like this, this operation will be done. FL is adjusted and FL minus Fs is equal to FL minus Fs, which is equal to IF. What is IF? IF is intermediate frequency here. (500 kilohertz). IF. Okay. Now see clearly. Okay. Now this 600 kilohertz, this 1600 kilohertz. What happened here? Now this is 1600 kilohertz. Here is also FL should be adjusted. FL should be adjusted to 2100. Why not? FL is adjusted to 200 because FL minus Fs, which is equal to IF, which is equal to 500 kilohertz. 2100 minus 1600 kilohertz, now which is equal to 500 kilohertz. Then what happened? Now this signal, listen carefully. This 1600 kilohertz signal is down converted to IF. This 1600 kilohertz signal is down converted to IF. Am I or not? And at the same time, this 600 kilohertz signal, this 600 kilohertz signal is also, this 600 kilohertz signal is also down converted to IF. Now what happened? Now see here, this is 500 kilohertz, center frequency is 500 kilohertz with a bandwidth of 10 kilohertz. Clear or not? This is 600 kilohertz with a bandwidth of 10 kilohertz. Now these are a passband or not? So 500 kilohertz is a center frequency, 600 kilohertz center frequency, means here somewhere a 500 kilohertz is existing or not? Because this is 610 and this is 590. Am I not? 590 to 610. Now this is 500 kilohertz. This is down converted to IF, which is 500 kilohertz. This is also down converted to IF. This is down convert to IF. This is also down converted. And both are creating a same image signal or not? Both are, this one This is the first one and this is the last one. Now these 1 and 2 are creating a same image or not, and therefore now this signal which is creating an image and causes interference to the required signal or not. Therefore now this 600 kHz signal, this 1600 kHz signal is causing, here I write, okay, this 1600 kHz signal, okay. Now Fs, which is equal to 1600 kHz. Now students, there is no doubt because 1600 kHz is within the AM range. Now Fs 1600 kHz is creating an image and causes interference to the required signal. What is the required signal? Fs is 600 kHz. Required signal, and that frequency is called as image frequency. Fsi equal to Fs plus 2Fi. If you have any doubt, see here, Fsi, which is equal to Fs is 600 kHz plus 2 into If is 500 kHz. Now 1000 plus 600, which is equal to 1600 kHz, is the image frequency. Understand not? Now this 1600 kHz is an image frequency. Okay. Now it is clear or not? Because you are having some doubt that 2000 is not within the boundary, but 1600 is within the boundary. But even that, now it will creating an image and causes interference to the required signal. Therefore, this frequency is called as image frequency and causes interference to the required signal. Any signal which is causing interference to the required signal, now that frequency is called as a noise frequency, noise signal, distorted signal. Okay, note down this first. Clear or not? Okay. Then when both are at the IF stage, see here, if this is at the IF stage, this one is also at the IF stage, will occupy the same frequency range. This fellow will occupy same 500 kHz and bandwidth of 10 kHz. That fellow is also occupying the same 500 kHz and bandwidth of 10 kHz. That is called as creating an image. Okay. So now I'll write one point by point. Okay. Now here, the image frequency causing interference, the image frequency causing interference to the required signal, so image frequency is to be considered as noise. Okay. The image frequency causing interference to the required signal, so image frequency is to be considered as a noise signal. Clear or not? So image frequency is to be considered as a noise signal. So you want a noise? No, we want to suppress the noise signal, right? Therefore, the image frequency should be suppressed, and it is as minimum as possible. And image frequency signal strength and image frequency signal strength, image frequency signal strength should be as minimum as possible. Clear or not? Once again I explain here. The image frequency is causing interference to the required signal. So image frequency is obviously any unwanted signal which is causing interference is called as noise. So the noise should be suppressed and image frequency signal strength should be as minimum as possible, because the noise strength should be as minimum as possible such that the signal to noise ratio should be as high as possible. Okay, note down. And this image frequency, the image frequency should be suppressed. The image frequency should be suppressed before the mixer stage. Because at the output of mixer, both will occupy the same frequency range. See here, now this is at the mixer stage, mixer output is nothing but IF stage. Now this 1600 kHz is down converted to IF, and this 600 kHz is also down converted to IF. Both will occupy the same frequency range at the output of the mixer. So at the output of the mixer, both will occupy the same frequency range. Therefore, the suppression should be done before the mixer stage, at the input of the mixer. At the output of the mixer, both will occupy the same frequency range. So suppression is not possible. Suppression is not possible at the output of the mixer. Assume a mixer is nothing but image frequency is nothing but a noise signal. So we want to suppress the noise signal strength should be as minimum as possible, such that the signal strength should be as good as possible. Signal to noise ratio is very, very high. Okay, note down those points. Clear or not? Therefore, what we required? we want to suppress at the input of the mixer. Therefore, now the fourth point is a tuned circuit is used at the input of the mixer. A tuned circuit is used at the input of the mixer to suppress image frequency. Okay, a tuned circuit is used to suppress the image frequency. So where is a tuned circuit? Now a tuned circuit, now I am indicating all tuned circuits with red line. Okay, now this is the tuned circuit. Now this is the tuned circuit which is used at the input of the mixer to suppress the image frequency. Now a tuned circuit along with mixer circuit is called as pre-selector. Pre-selector means proper care we should take before that cause will be affected. Okay, before that effect, then I want to take care of eliminating that suppression factor. Okay, a tuned circuit along with the mixer is called as pre-selector. Now how this tuned circuit characteristics? So how this tuned circuit characteristics? How this tuned circuit is designed to suppress the image frequency? Okay, now we'll see how this tuned circuit is designed. Now here I write this tuned circuit, how the characteristics of this tuned circuit. This is gain versus frequency characteristics of the tuned circuit. This is gain versus frequency characteristics of this tuned circuit. This tuned circuit is designed. This is Fs. This is gain at Fs. So generally FSI is high frequency. So this gain at FSI should be, see here, this gain at FSI should be as minimum as possible. So this is frequency, this is FSI, this is Fs. So this tuned circuit is designed, the gain at FSI should be as minimum as possible, because the signal strength at image frequency should be as minimum as possible, such that this is suppressed. Am I not? So this is the characteristics of tuned circuit. What is this? This is the characteristics of a tuned circuit to avoid image frequency. The tuned circuit should be designed like this. Okay. Or for example, this is the frequency characteristics. Now if this gain, which is equal to 1, so let us assume this gain is 0.001. Now this is gain at FSI, should be as minimum as possible, like this. Like this, you can design. Okay. Now, how to determine the suppression factor? To determine suppression factor, image rejection ratio is used. Image rejection ratio, IRR. Image rejection ratio is used to determine the suppression factor represented by alpha. Now, which is nothing but gain at Fs to the gain at Fsi. This is image rejection ratio. See here. Now, what is the gain at Fs? The gain at Fs is gain at Fsi should be as minimum as possible. Now, this is 0.001, which is equal to 1000. So, see here, the signal to noise ratio 1000 is acceptable or not? Now, the image rejection ratio is as image rejection ratio is as high as possible, such that image frequencies are suppressed.